potential energy, mechanical energy, heat, chemical, and even electrical energy. So all these forms of energy is what we bring out clearly when we talk about the first law of thermodynamics. Of course, we know that according to the basic concept we learned in our high school, we learned that energy can neither be created nor destroyed. We can only change or transform these energies into one form to another. So stay tuned to Augustine Chibuzor Mathphysics and enjoy what actually is the first law of thermodynamics. So let us take this. Energy conservation is what we refer to in respect to the first law of thermodynamics. So the first law of thermodynamics is this, that energy is conserved for any thermodynamic system, and that to say that energy cannot be created nor destroyed. Energy can only change from one form to another. It cannot be created nor destroyed. So energy is constant. Energy will always be constant. If you take internal energy and you add kinetic energy, you will get another form of energy, which is potential energy. This will give you another form of energy, which is mechanical. We have heat and we have chemical, and this also will be constant. So all these forms of energy, internal energy, kinetic energy, potential energy, mechanical energy, and heat, plus chemical and electrical energy will be constant in respect to the first law of thermodynamics. Now let us consider the concept of work when we talk about first law of thermodynamics, or generally, what is the concept of work in thermodynamics? In thermodynamics, work performed by a system is the energy transferred by the system to its surrounding. So we say that work is a form of energy, but it is energy in transit. So a system contains no work, and work is a process done by or on a system. We are going to bring out this concept clearly when we deal with calculation that involves work done in first law of thermodynamics. So in general, work is defined for mechanical system as the actions of a force on an object through a distance. And that's why we have said here that work is equals to force times distance, so that it will give us this equation. That W, which is the work done, will be equals to force times delta X, which is the change in that direction of the force. And that's why we say force times distance. Imagine this small illustration here. So force, if you apply force, it means that it has an impact in that system. So there is some distances that we need to multiply the work with, and that's why we say that work is simply equals to F times D, where work, W here, let's pick a pen. W is equals to work, and this usually is calculated in joules. We have F. F is equals to the force, and this force will be calculated in Newton. We also have V, which is the distance, and the distance will be equals to the displacement. And this displacement, of course, will be in meters. So it is good to pay attention to this, as this will help us drive with calculations. So the first law of thermodynamics, we still continue with our concept of work. We already have this. We already talked about work. having covered the concept of work in terms of the first law of thermodynamics, we see that work is a mechanical form of energy. Of course, we calculate work using force multiplied by distance. But let us recall the definition of pressure. We used to say that pressure as the physical force, it is defined as the physical force exerted on an object. So the force applied is a kind of perpendicular to the surface of object per unit area, and that's why we calculate pressure to be equals to force divided by area, and this will be equals to F divided by changing x squared, so that we can thus define work in respect to pressure to be the work done, that is delta W will be equals to PV, and this will be when we record the definition of pressure. So let us see pressure volume diagram, the relationship between pressure volume diagram, another way of depicting thermodynamic processes. I would like us to consider these processes. We have several kinds of processes in terms of thermodynamics. We have what we call the isothermal, we have the adiabatic, we have various forms of thermodynamics processes that we are going to be looking at in this video: isobaric, isochoric. We also have isothermal and adiabatic. But first of all, let us go back and look at the PV diagram, that is the pressure volume diagram, the relationship that involved in thermodynamic processes. The pressure volume diagram, abbreviated as PV diagram, is a graphical representation of change in pressure with respect to volume in a closed system. You have to note, it is in a closed system. PV diagrams are useful for determining the efficiency of a system, or what we call the work done by or to that system. That is why it was very important and prerequisite that we looked at the concept of work before coming to pressure volume diagram. So the classical example I can give is that of a cylinder and a kind of piston with some type of gas enclosed in the chamber. If we recall that the work of a process in a closed system from state 1 to state 2, this work will be represented. If I want to write it mathematically, we will simply have let's pick a clear pen.
Yes, Peter and Tika. Adams.
Somebody's supposed to present right now.
Okay, so
JK.
okay, I hope since my time is over, I think
Malimo met someone to be a presenter or how does it?
Okay.
as let me summarize as Mwalimu is making you to be a presenter. I've talked about first law of thermodynamics.
My side, I'm looking at Chibuzor is now reaching pressure, volume, graph, and all that. All we are in a different world. Yeah, it is the same one, but I think so. He has already finished.
Yes, actually I am done, and the video is available in the group, so we can look at it on our own individually. So what I have done is looked at the first law of thermodynamics. I also looked at the relationship between all this PV diagram and how we can involve the process of heat, that is the internal energy. Like we know, energy can neither be created nor destroyed. It is just a transfer from one form to another. So based on the video you have watched, if you have reaction or question, you can ask me or you write it down as we welcome another person. Thank you.
Thank you for that. Adams, who is the next? I think we should have the order.
The next person is JK.